Hi guys, in the previous video we had seen the law of large numbers. In this video we will learn how to calculate expected value. So this is what this line says. To get to expected value, we have to multiply each value of the random variable by its probability and add the products. So let us do the calculation and see. Assuming that we have a die and we are rolling a die. Now, in the case of rolling of a dice, we deal with 6 numbers. And when we roll a die, we can get any of these numbers. It could be 1 or 2 or 3 or 4 or 5 or 6. And the number appears, any of these numbers would appear randomly. Hence, the name random variable. Okay. What is the probability of getting any of these numbers? The probability would be 1 by 6, that is 0.1666667. So what does this line say? It says multiply each value of the random variable. So this is our random variable and these are the values. So multiply each value of the random variable by its probability. So every single number over here has the same probability, that is 0.166. So let us multiply that. We'll say RV multiplied by prob. So this is the result we are getting. So when we multiply 0.166, we are getting 0.166, and when we are multiplying by 2, 0.33, so on and so forth. And then it says add the products. That means these are the products, right? We have to add them together. So let us add that. We are getting 3.5. This is how expected value is calculated. That has already been done here. We have done this here. Okay, and we are getting 3.5. Let us take another example quickly. That is assuming that we have 10 numbers in a bag and we have to randomly pick any of these numbers. And when we do that, what will be the probability of getting any of those number randomly? It will be 1 by 10. Correct? And how many numbers are there? 10. So let us write those numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And now let us multiply probability by random variable. What we are going to get? We are going to get these products and then we have to sum them up. So what is the probability? 5.5. Okay. Let us also talk about, let me delete this. This has already been done below. Yeah, this is there already. This we just now saw. And a coin. Look, in the coin example, what happens? What is the probability? We have the probability of 0.5. 0.5 of getting heads and 0.5 of getting tails. Okay. Random variable. Let us consider random variable as 1 and 0. Now, what we will do? We will multiply the probability by the random variable. So random variable multiplied by prob. This is These are the products. We have to add them. Let us add them. We get zero point 0.5. Okay, good. So this is how we calculate expected value for any given experimentation that we will be doing for any probability. Now let us, okay, let me delete this as well. It is already done. So these three things which we have just now seen are already there. Let us do one exercise. This is a game. What does this game say? This says that flip a coin. If one gets tails, he loses $8. and if one gets heads, he wins $10. And to play the game, there is no fee charged. Okay, so let me repeat. It is a game involving flipping of a coin. One who plays this game gets $10 as a prize if he gets heads. But if he gets tails, he loses $8. So let us see how we can calculate expected value. Here, the probability of getting heads or tails is 0.5. And if my random variable gives me heads, then what we will get? We'll get $10. And if the random variable gives us tails, we lose $8. So again, the probability of getting heads is 0.5, the probability of getting tails is 0.5 as well. And we are multiplying with the respective numbers like 10 and -8. Let us see what we are getting. We get 1. And this is the gain, right? This is the expected value. It is coming positive. That means it is a gain. It is in favor of the player, in favor of the person who is playing this game. But how much fee he is paying? Nothing, zero, right? So this is the formula and we are getting 1. Okay, we have calculated the expected value for this game. That is perfectly fine. But can we really prove this to be true? To do that, let us do this. Let us consider this variable. Game 1 fee is 0. Game 1 heads, nothing with. When we flip the coin and get heads, we get $10. And if we get tails, we get -$8. That means we lose $8. So these variables have been created, and this n is nothing but we are flipping the coin these many times. And we are generating a random variable. Okay. In other words, we are flipping a coin these many times, and every time we will end up getting either heads or tails. So let me bring this and just see what is going on here. So this has already been written below, but let us write once again. So what we'll get? What will be the value of x? X will be appearing something like this. Okay? Heads, 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 tails, so on and so forth. Now, let us create a data frame. So next line is creating data frame for that random variable. Okay, done. Let us see how the data frame looks. This is how the data frame looks. Next, what is this? This line. What exactly it is doing? Let me remove this. This line is creating another column by the name game 1. If we get heads alongside this, we will write 10. That is $10. If we get tails alongside, we will write -8. Just see what happens. Created. Let us see df1 again. This is how it looks having run that. If you are getting heads, $10. If you are getting tails, -$8. We are losing. Okay. Done. What is next line? This line is populating every rows, every single row with 0. 0. We don't need to populate each and every row when the value is going to be same. But okay, fine. At least it will be easier to analyze each and every row if we write like this. Fine. Next, what is this? This column is game 1 net gain. What does this mean? Look, if we are getting heads, that means we are gaining $10. And what fee we are paying? Zero fee. So what it is resulting into? It is resulting into gaining $10 net. And when we get tails, we are losing minus 8. That we are losing $8. That the figure is minus 8. So what is the net loss? The net loss is minus 8 because we are not paying any fee. Had there been any fee, our loss would have been more than $8. Done. So this is also done. Let us see our data frame, how it looks. Let us see only 5 records. Okay, now what we can do? Now we are ready. We can calculate our expected value. How? We'll say sum, simply write sum, and then what we can say? DF1 game 1 net gain. What we are going to get? This is the figure. Let us divide it by n. 0.999298. That is sort of 1. Okay. Again, if we generate, this value is going to be different. Okay. So let us run it all over again. Right from here. 1, 2, 3. Okay. 4. This as well. And then run. So we will write it here and just compare. Let us write here. Yeah. Run it. Okay. Now 1.01. So since the variable is random in nature, we are not going to get the same figure again and again. But one thing is for sure, we are going to get a figure which will be very close to 1. Why? Because we are deploying the law of large numbers. How many times we are flipping the coin? These many times. 1000k times. Okay, good. So this is the result we are getting. Can we have a better demonstration of this number? Yes, we can have. So we will do one thing. We will create 2 more variables. What are those 2 more variables? Like it is already written here. Let me bring that up and discuss. Okay, here we go. See here, let me put this down here and we'll discuss about this now. Let me push it down, all this. Okay. Game 1 cumulative gain. Now what is cumulative gain? We will write this command to get another column. That column will give us cumulative game 1 net gain. So 10, then 20, then 30, then 40, then next what? Minus 8. It becomes 32. So on, so forth. So this is what is going to happen when we do this. So let us see this head. So this is cumulative gain. And next what? Game 1 expected value. What is happening here? Let us see. See, every line we are calculating expected value. Initially, the expected value calculated will be going like this. Look, tails, lost. Again tails. Again lost. Tails, losing. Tails, losing. Now heads, $10 gained. But what is my cumulative gain? Minus 22. Correct? It is resulting into minus 4.4. Clear? Okay. Now let us see the last records. Tail. Last 5 records. Look what we are getting. 1.013914. See here we already calculated 1.0139. See we already calculated. We are putting things in a much better manner by having this cumulative gain. and calculating expected value for each and every row. So the last row, this is going to give us this value, the last row. And that is what is our final expected value. Initially, it will be like this. And as gradually the number of flips increases, it is going to settle at 1. Let us see this through graph as well. Let me first declutter the entire thing. Since all the commands have already been written, this was just duplicate only to explain. So let us remove this. We will retain only the lines which are needed. Other things we will remove. Okay. We will keep this. I think we removed cumulative one. Okay. That should have been there. Okay. We will bring it. No worries. Okay. Here we have that line. We will bring and keep it here. Okay. Good. In fact, these lines we can keep in this cell itself, meaning we can remove this as well. Okay. Good. Now what we will do? That has already been done. Let me bring the lines from here. Okay. Let me run this all over again. Okay, good. Now this time we are getting 1003510. We keep running, we keep getting different value 1.013. Let us run it again. And remember that is 1.013. Now 0.989. Let us run again. Let us remember that is 0.989. This time 1.005. It will keep changing. However, it is guaranteed that it will be around 1. Good. So let us demonstrate this phenomenon through a graph. So first, we will draw a graph for initial 100 flips, 100 flips. Then for initial 500 flips. Then for initial 1000 flips. And then for all the flips. So see this graph, let us run this. This graph is going like this. Look, let us see head, how it is. Initial record. Look, the very first is -8. Correct? -8, -8. That is why you have horizontal line. It is representing two initial flips. And then -2. It has just gone here somewhere. Look, this is -2. Then -3.5, where I can see that. Okay, this is -3.5. Then -4.4. Next is what? Uh, we cannot really eyeball each and every value because from here to here there are 20 flips. But the point is, see, it is just going like this. Let us see at least 20 rows, initial 20 rows. So see, this is how it is. And these numbers, expected values, are shown over here. From here to here, 20. Correct? And this is 500. Now see, this line graph is settling around 1. See next, initial 1000, 1. And let us see for everything. The line got completely straightened. Why? Because we are expecting to get 1, and as the number has increased, the number of flips has increased, it is going to get settled at 1. And that is what is called expected value. So we have proven through this experimentation that if we will flip the coin again and again and again for this particular game, the value is going to be 1. So if anybody is going to play this game over a period of time, he is going to gain $1. Correct? That's all for now. Next time, in the next video, we will see another game. We will play another game that will be like this one. Let me show game. We will play this game again and we will change the value. Maybe we will have some fee to be given and these values, what we are losing and what we are gaining will be changed. And again, we will try to find out expected value. Thank you for watching and I will see you in the next video.